everyone, welcome to my YouTube channel. I am again in front of you with the lecture of class 12. Yes, the class 12 very important class for all of you. Today I will teach you differentiability, which is the very important topic, which is actually the backbone of the calculus. Okay, so this is very important topic. On this topic various chapter depend. Okay, so I will start with the basic concept, that means from the definition. So let's do the definition. What is the definition of differentiability? What is the definition? A function f is said to be differentiable at a point x is equals to a if limit x approaches to a fx minus f of a x minus a exists finitely. That means there should be some finite value of this function, this derivative. That means you have to take it into the two form, left hand derivative and right hand derivative. The left hand derivative in which we have taken x approaches to a negative, and in the right hand derivative we will take x approaches to a positive function. If both are equal, we can say that the function is differentiable. Okay, now come to the main point. If a function is differentiable at any point, it must be continuous. For if the function is continuous, it is differentiable, but the converse is not true, necessarily true. Converse is not necessarily true, but the converse is not necessarily true. Okay, so for every differentiable function, the function must be continuous. Okay, the function must be continuous, but for proving the function continuous, there should not be any necessity. There is not any necessity to make the function differentiable. Okay, so that we can write it as the converse is not necessarily true. Okay, come to the definition of this one. I will explain this definition by using one example, and I have taken this example from your NCERT book, exercise 5.2. This is question exercise 5.2, question number 9 of your NCERT book. So for your convenience, I will take these type of questions so that it become easy for you to understand the unsolved question as well as understand the unsolved questions. So I will start this from the left hand derivative. When you take the left hand derivative, limit x approaches to 1 negative, because the function demands for the point x approaches to negative 1, f of x minus f of 1 upon x minus 1. Okay, limit x approaches to 1 negative, this value is equals to mod x minus 1 minus, when you put 1 in place of x, 1 minus 1, that is 0 upon x minus 1. Okay, the limit x approaches to 1 negative, for the 1 negative the function is x minus 1 upon x minus 1, this and this will cancel, we get negative 1. Okay, now come to the right, this is left hand derivative, now come to the right hand derivative. In right hand derivative, I will take limit x approaches to 1 positive, there is negative, we have to take fx minus f of 1 upon x minus 1. Okay, now for the limit 1 positive, the function is same. When you put value 1 in place of x, 1 minus 1 is equals to 0 upon x minus 1. Limit x approaches to 1 positive, it will equals to x minus 1 upon x minus 1. These both are cancelled. Modulus function for 1 positive is positive and for 1 negative is negative. That means its value is equals to 1. Left hand derivative not equals to right hand derivative. Okay, this implies not differentiable. Okay, so this is not differentiable because left hand derivative not equals to right hand derivative. This is the way to apply the definition of left hand and right hand limits, and this is the way to solve the question for differentiability. Okay, now come to the basic formula you all have done in limits and derivative in class 11. The basic formula on which the whole chapter, these are the basic starting formulas. So I will write that formulas. What are that formulas? You all have done in class 11. What are that formulas? That is derivative of various functions, sine, cos, tan, cotangent, a raised to power x, constant function, exponential, logarithmic. So I will write that formulas for your convenience. Actually you all have done in class 11, but for your reminder I will will write that formulas. For your convenience, I will write that formulas. So important formulae. Important formulae. Okay. The first is derivative of x raised to power n, that is nx, n minus 1. Okay. The second is derivative of a raised to power x. This is x raised to power constant, a constant raised to power x, that is a raised to power x log a. Third is derivative of log x, that is 1 upon x. Fourth is derivative of exponential of function, that is exponential of function. Okay, the fifth is derivative of constant function, that is 0. These are the different function I have written down. Now I will do the trigonometric function and inverse trigonometric function. So come to the trigonometric function, that is derivative of sin x, that is cos x. Derivative of cos x, that is minus sin x. Okay. Derivative of tan x, that is secant square x. Derivative of, this is 7th and 8th. This is 8th, now come to the 9th. 9th is derivative of sin cos tan. After that cot x minus cosecant square x. 10th is derivative of cosecant x, that is minus cosecant x cot x. Derivative of secant x, that is secant x tan x. Okay. Now these are the trigonometric formulas. These are exponential functions, logarithm function, constant and so on. Now in the class 12 we have one more type of function, that is inverse trigonometric function. I will write the formulas of that function also. So that is the derivative of sine inverse x, that is 1 upon under root of x square minus x. 13th, derivative of cos inverse x, that is negative 1 upon, this is 1 minus x square, not, this is 1 minus x square. This is 1 minus x square in the negative form. 14th, derivative of tan inverse x. This is 1 minus x, this is 1 upon 1 plus x square. Derivative 15th, that is derivative of cot inverse x, that is 1 upon minus 1 upon 1 plus x square. There is only one difference between sine and cos, that is only of negative. And between these two there is only one difference, that is of negative. Now come to the secant inverse and cosecant inverse. What is the formula of secant and cosecant inverse? That is very simple. So I will write that formulas. Cosecant inverse x and secant inverse x. So this is, I will draw from this side. Okay. So what are the basics formulas? This is question next 16th formula, that is 16th is derivative of secant inverse x, that is 1 upon x square minus 1. Okay, so this is the x upon x square minus 1. Now 17th formula, derivative of cosecant inverse x. There is one formula change, that there is one sign change only between these two formula. So these are the basics formula of derivatives. Okay, now come to one more formula, that is if the function is given as ax plus b raised to power n, how we can write it as, that is n comes in front, ax plus b raised to power n minus 1, and further the derivative of interior function, that is ax derivative is a and b is equals to 0. Similarly, we have so many values. There's, for example, tan ax, that is secant square x into a. So I will do by using the chain rule. What is this chain rule? I will write this chain rule. Before doing that chain rule, I will write the algebra of derivatives. Okay, what is that algebra of derivative. I will write the algebra of derivative functions. So what is that algebra of derivative functions? Very simple. Very simple. What do you mean by algebra? You all know what is algebra? The algebra is that values in which we talk about the addition, subtraction, multiplication and division. Okay, so let's do the algebra of derivative function. Algebra of derivative function. Derivative functions. Okay, first is, if we talk about the derivative of u plus or minus, both works say in the same manners. Okay, you can take the derivative, different derivative of each function if there is addition or subtraction sign between two functions. Second is, if you talk about the two functions which are present in the product, that is the product rule, that will equals to u derivative of v plus v derivative of u, right? If we talk about the division sign, derivative of division, that u upon v, how we can solve? That is v square, v derivative of u minus u derivative of v. So this is the way to solve the questions by taking two different functions, either in addition, either in subtraction, either in multiplication or either in division. So we talk about the four operations here. Okay, now come to the chain rule. What is chain rule? This is the first rule in which you have to start 5.2 exercise. What is the chain rule? The chain rule is, if y is function of x, okay, if y is function of x and x is function of u, then this is u, then what has happened? Then y is composition function of, and we can write it as and, y is composition function of u, then how we can find du upon dx? Dy upon du, not du upon dx. I want to find dy upon du because the final composition function is y in the form of u. I want to find dy upon du. How we can find? By taking two functions. The function y, which is in the form of x, we will take it as dy upon dx into, with the multiplication of x with respect to u, that dx upon du. These both will cancel and we get dy upon du like this. So this is the chain rule. If there are two different functions in the form of third, so we can solve this in this way. Okay, I will start the exercise, solve that question for you by using chain rules. So I will start that exercise. That exercise is 5.2. How to solve? Very simple exercise. I will write the question for all of you. From the first exercise, one thing you have to keep in your mind, that the exercise first weightage of exercise first is either 1 mark or 2 marks. Okay, so your time management should be according to the 1 mark and 2 mark. So I will write the question. This is exercise 5.2, question number first. That all questions are of differentiate only, based on the differentiate. The first is sine x square plus 5. So how you can differentiate? Y, I will take it as y. Okay, dy upon dx, this is the solution. Dy upon dx, that will equals to sine's derivative. First of all, take the derivative of sine x square plus 5 and the further derivative of x square plus 5, that will equals to cos x square plus 5, and the derivative of this one is 2x. So I will write it as 2x cos x square plus 5, like this. Okay, this is known as the chain rule. You have to first do the derivative of this one, then the interior function. Now come to the second one. The second one is sine cos sine x. Y is equals to cos sine x. Okay, how you derivative, when you take the derivative, this is the solution. The derivative of cos function, that is minus sine x, and the further the derivative of sine x, that is sine x, that is cos x, minus sine x, and the further derivative is cos x. So this is the way to solve these two questions. Now come to the third question. What is the third question? Third question is secant tan and root x. Third question is you have to take secant tan root x. This is little bit lengthy because in these two we have only two functions. Okay, here we have 1, 2 and 3 functions. So I will solve like this: dy upon dx. This is the solution. The derivative of secant x, that is secant x tan x. So this behave like x, secant x tan x. Okay. Now the derivative of tan root x. Now come to the derivative of tan, that is secant square x. So I will write secant tan root x, tan root x, and secant is secant square. The tan's derivative is secant root x and further derivative of root x. Now root x means x raised to power 1 by 2, right? When you do the derivative of this function, it comes in front 1 by 2, x raised to power 1 by 2 minus 1. When you take the LCM, it becomes x raised to power negative 1 by 2, that means 2 root x. So I will write this derivative in this place. Okay, I will write from this side. This is the way to solve under roots derivative. So I will write, how we can write? I will write the values like secant tan root x, tan root x. This is secant square root x, and here's derivative is 2 root x. So this is the way to solve the question. Now come to the question number 4. That is sine ax. Very simple question. Okay, so I will write that question. Very simple. Question is sine ax plus b. Sine ax plus b. Question number 4. Very simple. Y is equals to sine. This is sine ax plus b. Ax plus b. How you can find? Simple. Dy upon dx. When you take the solution, sine's derivative is cos ax plus b, and when you further do the derivative of this will equals to a. B has a constant and is a constant, and its value is equals to 0. Okay, now come to the question number 5. That is y is equals to sine ax plus b, sine ax plus b upon cos cx plus d. How you can solve it? The question is very simple. Take the solution. How you can take dy upon dx, that will equals to, in the denominator there is cos square cx plus d, right? In the numerator cos cx plus d. Okay, derivative of sine. I will rub from that side so that it become easy to understand for all of you. Okay, I will rub from this side because it is a lengthy line. I will write this lengthy line that demands for more space. That's why derivative of ax plus b minus sine ax plus b, derivative of cos cx plus d. Okay, so this is the way to solve the. Now apply the solution cos cx plus d. Here sine is equals to cos ax plus b. Further, when you do the derivative of the interior function, the derivative of ax is a and the derivative of b is equals to 0 minus sine ax plus b. What is the derivative of this? This is minus sine, that comes in positive, sine cx plus d, and further cx derivative, that is further is c, and d is equals to 0, divided by cos cx plus t. No need to do further simplification. No need to do further because no simplification is for